In this video, I'll be teaching you how to define your own APL operators. So if you are very familiar with that, if you know how that works, feel free to skip this video. Otherwise, sit tight. I think you might have noticed by now that APL functions take arrays as arguments, and APL operators, like the jot and this, so the beside operator and the power operator, those can take functions as operands. We've also seen each. And these functions are usually passed in on the left. So for example, each operator takes a function on the left. And sometimes they take functions on both sides, like the beside operator. But you've also seen cases in which you can use arrays as the operands to the function. For example, this carries the number 4 as the right argument to f, and this carries 4 as the left argument to f. And also this applies f 4 times to something on the right. So whenever you need to implement something that accepts some function and then uses that function to do something else, you need to define an operator. A function won't cut it. But luckily for you, it's fairly easy to implement your own operators. They just have a syntax that is very similar to diffs, and with that syntax you can create DOPs, which are dynamic operators. So let's go ahead and open the editor window, and let's create an if operator. And what we want for this operator to do is, let me go ahead and comment it. If we use it, and by the way, let me use underscores in the name as well, because it helps me realize that this is an operator, because it has these underscores representing the functions that are missing. So let's say f if g, and I have to put spaces in here, so f if g will apply f if and only if g evaluates to 1. So the idea is g will represent a Boolean function that takes your argument and does some type of check, and then if the check passes, you apply f, otherwise you leave the value untouched. And for that we will use the power operator that we've seen in the previous video, which can be used to apply a function 0 times or 1 time. So all we have to do is, we're going to take our, okay, now this is where the syntax kicks in. So this looks like a diff, right? As of now, I haven't done anything that tells the interpreter that this is actually an operator and not a function. Yeah. And the way you tell the interpreter that this is actually an operator is by using the functions it gets as operands. And it's fairly easy to do so. The left operand is alpha alpha. So this should be together. If you space them, this means the left argument of the function and the left argument of the function, but two alphas in a row mean the left operand. And similarly, omega omega means the right operand of the operator. And by default, operators only take a left operand. So if you want a right operand, you also have to specify omega omega. So let me go ahead and increase this a little bit so we can see the whole comment. And let's say, for the sake of simplicity, let's say we only want to apply this to a single argument, so we don't want to create a function that takes an argument on the right and on the left. So f if g omega will apply f to omega if and only if g of omega evaluates to 1. So this is what we want to do. So the first thing we need to do inside our operator is to find this value, g of omega, and g is the right operand. So this is actually omega omega of omega. So this is the Boolean check. And now we want to apply f, which is the left operand, that is alpha alpha, power either 0 or 1, depending on what g returns. And then, because of stranding, we have to parenthesize all of this and apply it to omega. Now let me press escape so that if gets saved, we changed the name, so I should open the correct window now. I just wanted to save it. You can check it over there. Now let's try and increment. So I still have this function from a previous video. This is a function that increments. So let's increment some number if the number is positive. So this is me carrying a 0 to the greater than. So this is a function that reads is greater than 0, and let me increment 5 if it is greater than 0. And it is, so we get a 6. Okay, so now let me increment -5 if it is greater than 0. It's not, so we don't increment it. And so this is the basic stuff about creating your own operators. They look, or at least the ops, they look exactly like difference in that you have the curly braces here and here. The only difference is in that you can recognize an operator because it will be using alpha alpha and or omega omega. And by default, an operator has to take an operand on the left. So you can make an operator that only takes something on the left. You cannot create an operator that only takes something on the right. And finally, these underscores next to the name of the operator, these are just clues for you to know where functions should go. You don't really have to name your operators like this. It's just some style guide that I like to follow. And by the way, I'll link to the style guide in the description below. So that's it. Now we know how to define our own operators. We will be doing this, we will be using this in our next video when we implement the forward pass of the neural network.